Hey guys, it's Miss Hopkins here, and today we're going to look at the empirical rule and work some example problems using that. So if you'll recall, the empirical rule works with a normal distribution curve, and we've seen before in previous videos that when you have data that is normally distributed, it follows a bell-shaped curve with mean in the middle and standard deviations on either side. And between -1 standard deviation and 1/68% of your data falls. Between 2 standard deviations on either side, 95% of your data falls. And between 3 standard deviations on either side, 99.7% of your data falls. So we're going to do a couple of problems using that information. Here's the first one. I would suggest copying it down on your paper so that we can work it together. We're going to do 2 together, and then I believe I've got 1 for you to try on your own. So, example 1 says, suppose the distribution of monthly earnings for all people with a bachelor's degree is normally distributed with a mean of $2,116 and a standard deviation of 455. The first question is asking what percent of individuals with a bachelor's degree earn less than $1,661 a month. So what I would do to begin with is I would go ahead and draw a picture of what we are given here in this problem. So we're going to draw our bell-shaped curve. Okay, we know that the mean of our data is 2,116. We know that the standard deviation is 455, so that puts 1 standard deviation to the right at 2,571. Maybe we can get it on there. There we go. Nope. Okay, 2 standard deviations to the right would be 3026. And then 3 standard deviations to the right would be 3481. Okay, going to the left. All right, that is the worst looking curve ever. Let's start that again. Okay, we will draw what our distribution looks like. The mean of 2,116 will be in the middle. At 1 standard deviation to the right, we will have 2,571, and all we're doing is we're adding that 455 to the mean to get where the standard deviations lie. Okay, when we add it again, we're going to end up with 3026, and then 3 standard deviations to the right will be 3481. Okay, going to the left, when we subtract 455, the first standard deviation to the left would be at 1661, sorry. All right, the second one would be at 1206, and then 3 standard deviations to the left would be at 751. Okay, so now we kind of know where all of our values lie. So the question is asking what percent of the individuals with a bachelor's degree earn less than $1,661 a month. So what we're looking for is the percentage that falls right in here. That percentage right there. Okay, so I know that this area right here, from the center all the way to the left, okay, that would be 50%. 50% of the data falls below the mean. Okay? I know that because from one standard deviation to the left to one standard deviation to the right, this area right in here, I know that is 68. So that means that this part that's just on the left of it, left of that mean value, the green part right there would be 68 divided by 2. This part right in here would be 68 divided by 2 from here to here. So what I can do to get the area that I want now is I can take the 50%, okay, I can subtract 68 divided by 2%, which is 34, and I end up with 16%. And so this tells me that approximately 16% of the people with a bachelor's degree would earn less than $1,661 per month. All right, let's look at the second example. Okay, the second example is asking what percent of individuals with a bachelor's degree would earn more than $1,206 a month. So again, we're going to draw our normal distribution. Okay, we know that our mean value, which is right in the middle, is 2,116. Okay, we want more than 1,206, and we found just a second ago that the second 2 standard deviations away from the center to the left puts us at the $1,206 mark. So we're looking for how many people earn more than that. So the percentage that we're going to try to find here will be this percentage that's in here. Okay, to the right of the 1,206. Okay, let's think about what we know. We know that this area in here, this whole region to the right, okay, to the right of the mean is going to be 50%. Okay, we know that from 2 standard deviations on either side is your 95%. And so if we just want this part right here, okay, if we just want this part right here, then that's going to be 95 divided by 2. So we would take the 50% and we would add the 95 divided by 2%, which ends up giving us 97.5%. So we could say that 97.5% of the people with a bachelor's degree earn more than $1,206 per month. Let's look at our third example. What percent of people with a bachelor's degree earn between $3,026 and $3,481 per month? So if we look at where our standard deviations lie, one standard deviation above the mean is at 2,571. 2 standard deviations is at 3,026. If we extend this out a little bit further, 3 standard deviations is 3, 4, 8, 1. And so what we're looking for in this problem is the percent of people that earn between a given amount. So the percentage that we're going to be looking for in this problem is going to be in between these two amounts right here. Okay? All right. So, if we think about the fact that from, let's see, how do we want to do this? Okay, from here to here, from the center out to 3 standard deviations, it would be 99.7 divided by 2%, because on either side, if you're 3 standard deviations, to the left and to the right, that whole percentage is 99.7. So just the right-hand side of it would be 99.7 divided by 2. Okay, we also know that this part in here, let's see if I can shade this in. Okay, let's pick a different color. Okay, this part in here, from here to here, would be 95 divided by 2. So the part that we want will be 99.7 divided by 2 minus 95.2, or 95 divided by 2. All right, that's going to give us about 2.35%. So we would say that 2.35% of the people earn between $3,026 and $3,481. Here's a problem for you to try. IQ scores of American teenagers are normally distributed with mean of 100 and standard deviation of 10.5. What percent of teens have IQs between 89.5 and 121? Remember to draw the picture first. You might want to stop the video, work the problem, and then when you go to the next section, I'll have the answers for you. We'll see how well you did. All right, here's the answer. The answer is 81.5%. The way you would work it is you would show where the values lie. So if the standard deviation is 10.5, to the right of your mean, your first standard deviation would be 110.5. The next one would be 121. To the left, one standard deviation away would be 89.5. 2 would put you at 79. In this particular problem, you're looking for the pink area that is shaded in. So that would be the sum of 68 divided by 2%, which is this part, and 95 divided by 2%, which is this part. And you get the sum of that to be 81.5. Hope you got it right. That's all for now. See you guys later. Bye.